Is Mars humanity's next home, or just the beginning of our cosmic journey? From the red deserts of Mars to distant exoplanets orbiting faraway stars, we'll take you deep into the challenges, innovations, and philosophical questions surrounding our next great leap, becoming a multi-planetary species. Join us as we explore the latest scientific discoveries and technological breakthroughs that are bringing us closer to the stars, and examine the ethical and societal implications of colonizing other worlds. Whether you're a space enthusiast or just curious about humanity's future among the stars, join the conversation and let your imagination soar. This is the future of space travel, colonizing Mars and beyond. As we continue to push the boundaries of space exploration, one question looms large. Which world will be humanity's first true home away from home? While the cosmos is vast and full of wonders, Mars stands out as the most viable candidate for establishing a permanent human presence. But why is Mars so appealing? And what makes it the most suitable destination for our cosmic dreams? One of the primary reasons Mars has captured our attention is its relative proximity to Earth compared to other celestial bodies. At an average distance of about 140 million miles, Mars is easily reachable within a human lifetime. This nearness allows for more frequent communication and resupply missions, making it more feasible for sustained human habitation. Moreover, Mars is the most Earth-like planet in our solar system, offering several intriguing similarities that make it a compelling choice for colonization. Its solid surface allows for the construction of physical structures, providing shelter from the harsh Martian elements. Additionally, Mars has an atmosphere, albeit thin and primarily composed of carbon dioxide, which can be utilized for various life support functions. Furthermore, evidence suggests that Mars may have once harbored liquid water and could have supported microbial life. The potential for discovering fossils or extant extremophiles would not only be scientifically significant, but also serve as an inspiration for those venturing to the red planet. However, it's important to acknowledge the harsh realities of Martian existence. Temperatures on Mars range from an average of -81 degrees Fahrenheit to a sweltering 70 degrees Fahrenheit. The thin atmosphere and lack of an ozone layer expose the surface to high levels of harmful radiation. Establishing a self-sustaining habitat and securing resources such as water and food will be crucial for long-term survival. Nevertheless, these challenges also present exciting opportunities for innovation and discovery. Developing technologies to overcome them will not only advance our understanding of planetary science and human adaptation, but also push the boundaries of engineering and materials science. To prepare for life on Mars, scientists and engineers are working tirelessly to develop innovative solutions. NASA's Perseverance rover has been exploring the Jezero crater on Mars since 2021, searching for signs of past life and testing technologies for future human missions. The rover's instruments include a drill that can extract core samples from rocks and soil for analysis, as well as a device called MOXIE that can convert carbon dioxide from the Martian atmosphere into oxygen. SpaceX, led by the visionary Elon Musk, is developing the Starship, a fully reusable launch vehicle designed to transport both crew and cargo to Mars and beyond. With a planned capacity of over 100 tons, Starship will be capable of delivering large amounts of supplies and equipment necessary for establishing a Martian colony. As we delve deeper into our exploration of Mars, we must also consider the ethical implications of venturing onto an alien world. Protecting planetary environments from biological contamination is of utmost importance. Both NASA and SpaceX adhere to strict protocols to prevent any potential cross-contamination between Earth and Mars. By taking these precautions, we can ensure that any discoveries on Mars remain pristine and untainted by earthly life. The allure of Mars is undeniable, offering a unique combination of scientific intrigue, exploration, potential, and possibilities for human settlement. As we continue to unlock the secrets of the Red Planet, its appeal as our next home away from home grows stronger. But what if our sights are set even higher? Could the future of space travel lie in the exploration and colonization of distant worlds beyond our solar system? The discovery of thousands of exoplanets has opened up a realm of possibilities for interstellar exploration and potential colonization. Among these exoplanets, some have been identified as potentially habitable. Located in the so-called Goldilocks zone, not too hot and not too cold, where conditions might be suitable for life to flourish, the nearest potentially habitable exoplanet is Proxima Centauri b, orbiting the red dwarf Proxima Centauri, which is approximately 4.2 light-years away. While the exact conditions and habitability of these distant worlds remain uncertain, the sheer number of exoplanets suggests that Earth-like planets are likely abundant throughout the galaxy. However, the vast distances involved in interstellar travel pose significant challenges. Even at a fraction of the speed of light, reaching these distant star systems would take many years. Traveling at 10% the speed of light, for instance, would still take over 40 years to reach Proxima Centauri. This presents numerous hurdles, including the need for advanced propulsion systems, life support, navigation, and communication over interstellar distances. Current propulsion technologies, such as chemical rockets, are woefully inadequate for interstellar travel. Even the most powerful rocket engines would take centuries to traverse the expanse of our galaxy. To achieve interstellar travel within a reasonable time frame, we would need revolutionary advances in propulsion concepts such as nuclear thermal propulsion, solar sails, fusion drives, and other futuristic technologies. These propulsion methods could potentially accelerate spacecraft to a significant fraction of the speed of light, allowing for more feasible interstellar journeys. Nuclear thermal propulsion involves using a nuclear reactor to heat a propellant, which is then expelled from a nozzle to generate thrust. Solar sails harness the momentum of photons from the sun to propel a spacecraft, though their effectiveness diminishes over time due to the inverse square law of radiation pressure. Fusion drives, on the other hand, utilize the energy released from nuclear fusion reactions to produce thrust, offering a more powerful and efficient means of space travel. One promising concept known as Breakthrough Starshot aims to achieve interstellar travel by propelling a nanocraft equipped with a light sail at 10% the speed of light or greater. This ambitious project envisions the use of powerful lasers or particle beams to accelerate these nanocrafts, opening up the possibility of reaching nearby star systems within a matter of years. While the technological challenges are immense, the long-term goal of interstellar colonization holds tremendous allure. Establishing self-sustaining colonies on distant worlds could provide humanity with a safeguard against extinction and allow us to explore and settle new frontiers in the galaxy. However, it's essential to recognize that interstellar colonization lies many decades or even centuries ahead. The immense distances and technological challenges involved make it a daunting task that will require sustained effort, international collaboration, and groundbreaking innovations. Our journey through space travel and the prospect of colonizing other worlds inevitably raises profound philosophical questions. What does it mean for humanity to spread beyond Earth and establish a multi-planetary civilization? How will we balance the preservation of our natural heritage with the pursuit of scientific discovery and resource extraction? And how will we ensure that the expansion of humanity into the cosmos is conducted ethically and responsibly? As we venture further into the unknown, we must confront these questions head-on and engage in thoughtful discussions that encompass the ethical, social, and environmental implications of our actions. Moreover, the ethics of space exploration extend to the very essence of our mission. We have a responsibility to protect not only other celestial bodies from contamination, but also our home planet Earth, safeguarding the delicate balance of our biosphere and preserving its unique qualities for future generations should be paramount in our considerations. Furthermore, the issue of space resources and ownership raises complex questions. As we seek to establish colonies on other worlds or mine asteroids for resources, we must determine who has the right to own and utilize these extraterrestrial materials. International law and governance frameworks must evolve to address these issues and ensure equitable access and utilization of space resources. As we stand on the precipice of a new era in space exploration and colonization, we have the opportunity to shape the future of humanity among the stars. Let us embrace this moment with wisdom, foresight, and a deep sense of responsibility. The universe beckons us to explore, discover, and settle beyond our pale blue dot. It is up to us to ensure that our journey among the stars is one that is not only filled with wonder and adventure, but also guided by ethical considerations, environmental stewardship, and a commitment to the betterment of our species as a whole. Thank you for joining us on this journey through the future of space travel, colonizing Mars and beyond. If you enjoyed this exploration, we invite you to subscribe to our channel for more captivating journeys into the realms of science, technology, and space exploration. Together, let's continue to push the boundaries of human knowledge and endeavor. As we look to the stars, let us carry with us the spirit of exploration, innovation, and unity as we strive to create a future where humanity's journey among the cosmos knows no bounds.